Aerial application, or what was formerly referred to as crop dusting, involves spraying crops with crop protection products from an agricultural aircraft. Planting certain types of seed are also included in aerial application. The specific spreading of fertilizer is also known as aerial top dressing in some countries. Agricultural aircraft are highly specialized, purpose-built aircraft. Today's agricultural aircraft are often powered by turbine engines of up to 1,500 horsepower and can carry as much as 800 gallons of crop protection product. Helicopters are sometimes used, and some aircraft serve double duty as water bombers in areas prone to wildfires. These aircraft are referred to as seat, single-engine air tankers. History: aerial seed sowing 1906. The first known aerial application of agricultural materials was by John Chater, who in 1906 spread seed over a swamped valley floor in Wairoa, New Zealand, using a hot air balloon with mobile tethers. Aerial sowing of seed still continues to this day with cover crop applications and rice planting. Crop dusting 1921. The first known use of a heavier-than-air machine to disperse products occurred on 3 August 1921. Crop dusting was developed under the joint efforts of the U.S. Agriculture Department and the U.S. Army Signal Corps Research Station at McCook Field in Dayton, Ohio, under the direction of McCook engineer Etienne Dormoy. A United States Army Air Service Curtiss JN-4 Jenny piloted by John A. McCready was modified at McCook Field to spread lead arsenate to kill catalpa sphinx caterpillars at a catalpa farm near Troy, Ohio in the United States. The first test was considered highly successful. The first commercial operations were begun in 1924 by Huff-Dalland Crop Dusting, which was co-founded by McCook Field Test Pilot Lt. Harold R. Harris. Use of insecticide and fungicide for crop dusting slowly spread in the Americas and to a lesser extent other nations in the 1930s. The name crop dusting originated here, as actual dust was spread across the crops. Today, aerial applicators use liquid crop protection products in very small doses. Top dressing 1939 to 1946. Aerial top dressing, the spread of fertilizers such as superphosphate, was developed in New Zealand in the 1940s by members of the Ministry of Public Works and RNZAF, led by Alan Pritchard and Doug Campbell. Unofficial experiments by individuals within the government led to funded research. Initially fertilizer and seed were dropped together. 1939. Using a window-mounted chute on a Miles Whitney Strait. But by the end of the 1940s different mixtures of fertilizer were being distributed from hoppers installed in war surplus Grumman Avengers and C-47 Sky trains, as well as some privately operated de Havilland Tiger moths in New Zealand. And the practice was being adopted experimentally in Australia and the United Kingdom. Purpose-built aircraft. In 1951, Leland Snow begins designing the first aircraft specifically built for aerial application, the S-1. In 1957, the Grumman G164 AgCat is the first aircraft designed by a major company for ag aviation. Water bombing 1952. Aerial firefighting, or water bombing, was tested experimentally by Artcellers Skyways Air Services in Canada in 1952, dropping a mix of water, fertilizer and seed, and established in California in the mid-1950s. Night aerial application 1973–present. Aerial application at night is mostly liquid spray and is conducted in the southwestern U.S. deserts. The increased heat, scheduling conflicts with farm workers in the fields and honeybee activity reduced the effectiveness of spraying in daytime. In high-temperature areas, the insects would travel down in plants in daytime and return to the top at night. The aircraft, both fixed-wing, autogyros, and helicopters, were equipped with lights, usually 3 sets. Work lights were high-power and aimed or adjustable from the cockpit. Wire lights were angled down for taxiing and wire or obstruction illumination. And turn lights were only turned on in the direction of the turn to allow safe operation on moonless nights where angle of entry or exit needed to be illuminated. Some aircraft were equipped with an elongated metal wing called a spreader, with inbuilt channels to direct the flow of dust such as sulfur, used on melons as a pesticide and soil amendment. Very little pesticide dust was used day and night in comparison to spray, because of the difficulty in drift control. Workers on the ground, called flaggers, would use flashlights aimed at the aircraft to mark the swaths on the ground. Later, GPS units replaced the flaggers due to new laws restricting use of human flaggers with some pesticides. GPS systems also provide precise guidance for the applicator. Agricultural chemicals have also kept pace with advancements in technology, and have been influential in the growth of the agricultural aviation industry. In the 1930s, aerial applicators arrived in the northern states to war against insect and disease pests which threatened fruit and vegetable crops. After World War II, the industry expanded into the western states, where the development of new chemicals made possible the control of weeds and insects in cereal grain crops. Some of these new chemicals proved very useful in controlling various insects that carried diseases dangerous to humans. Countries that previously had no control over malaria and river blindness were provided with chemicals which helped save hundreds of thousands of lives and reduce the suffering of millions. All during the 1950s. Crop production continued to rise and disease declined as a result of chemical controls. Aerial application accounts for just under 20% of all applied crop protection products on commercial farms. The industry also provides firefighting and public health application services according to a 2012 NAAA survey. The 5 most common aerially treated crops are corn, wheat, barley, soybeans, pastures, rangelands and alfalfa. But aerial application is used on many more crops grown in the U.S. Approximately 1,350 aerial application businesses are in the U.S., and 1,430 non-operator pilots. 94% of aerial application business owners, operators, are also pilots. Aerial application businesses are located in 44 states, all but Connecticut, Hawaii, Nevada, Rhode Island, Vermont and West Virginia. Today's ag aircraft use sophisticated precision application equipment such as GPS, Global Positioning Systems, GIS, Geographical Information Systems, Aircraft Integrated Meteorological Measurement System, AIMMS, Real-Time Meteorological Systems, Flow Control Valves for variable rate applications, single boom shut-off valves and smokers to identify wind speed and direction, according to the U.S. Bureau of Labor Statistics. In 2005, U.S. crop duster pilots earned an average annual wage of $63,210. Unmanned aerial application. Beginning in the late 1990s, unmanned aerial vehicles are also being used for agricultural spraying. This phenomenon started in Japan and South Korea, where mountainous terrain and relatively small family-owned farms required lower cost and higher precision spraying. As of 2014, the use of UAV crop dusters, such as the Yamaha R-Max, is being expanded to the United States for use in spraying of vineyards. See also pesticide application, sprayer, aerial top dressing, ultra-low volume spray application. Johnson, Mary Ann, McCook Field 1917–1927. Landfall Press. Dayton, Ohio. 2002. ISBN 0-913428-84-1. pp. 190–191.